flow will be equal, this particular case, and the temperatures of the two regions, as I've demonstrated, will also be equal. Now in that case, we're quickly going to learn about some of the symbols that we're going to use in designating heat as a form of energy that is involved in this thermodynamic situation. So for that case, I'll just give a demonstration for two containers. So this is a first container. Okay, just draw it like this. It's a container that is like this. And another one like this. My drawings will make them a little bit. Okay. And then I make another one. So let's have two setups there, whereby these two containers are going to represent a system. Outside the containers, we are going to have what we call a surrounding. And then we are going to have heat moving into the system from the surrounding across the boundaries, and the heat being dissipated or moving away from the system across the boundaries. Then for that case, there are specific terms that we are going to use to symbolize these particular two scenarios. And before we proceed now, as we said about symbolizing or abbreviation for heat, we're going to use the letter Q to refer to heat. In that case, now as we know from chemical reactions, in a chemical reaction we have two parts, which is the reactant side and then the product side. So which means reactants react in that process, and then we have products on our right side. So in that case, as we are going to demonstrate heat, we are going to be treating it as a reactant. So it will be used at the left part of the equation, which represents the reactants. So in that case, we should give an equation to demonstrate for that general aspect that we are talking about, whereby heat will always be treated as a reactant. Now, back to our two scenarios that I'm talking about, that we were trying to demonstrate about the surrounding and the system. If heat is taken into the system, as I've demonstrated for scenario A and B, in scenario A, heat is taken into the system from the surrounding across the boundaries. In scenario B, heat is given away from the system to the surrounding. Now we have specific terms that we use to refer to these two different types of scenario. The first one, when heat is absorbed by the system from the surrounding, that is scenario A, we call that endothermic. Endothermic term from the word heat. So endothermic, heat is being taken from the surrounding into the system across the boundaries. And when the reverse is being experienced, heat is given away from the system to the surrounding across the boundaries, or it is evolved, then we refer to that one as exothermic.